Hello and welcome. In this tutorial, we will learn about Boolean data type and its operators in Python, so let's get started. Up until this point, we have looked into four main data types in Python: int type, which holds integer numbers, float type, which holds decimal numbers, and string type, which holds a sequence of characters or textual information. In this section, we are going to look at another very important data type that is called a Boolean. Booleans are used to check for the truth of an expression, so Booleans have only two outcomes, true or false. For example, suppose you have two variables, x equals 2.5 and y equals 3. Now, it is a fact that x does not equal to y, so to check the equality in Python whether x equals y or not, you can use the double equal sign. Do not confuse double equal sign with the single equal sign, as the latter is used to assign values to variables. Now, here in this example, you see that when we check if x is equal to y using the equality operator, the output is false, meaning that x does not equal to y. Another example would be to check if x is less than y. Indeed, x is less than y, so the output of this Boolean expression is true. Booleans have a bool data type. You can check this by writing type of x less than y or any another Boolean expression. Equality is one of many Boolean operations. Here is a summary of other Boolean operators to check whether an expression is true or false. As shown here, you can check if two variables are equal to, unequal to, greater than, less than, greater than or equal to, and less than or equal to. Although Booleans have bool type in Python, their backend interpretation is considered to be numeric. True in Python is equal to 1, and false is equal to 0. Here in this example, adding false value to a float value of 2.5 in variable x will yield a value of 2.5. Since the variable y is equal to the value of x plus a true value, the output will be 3.5. Boolean operators are the ones that take a Boolean type as input and outputs a Boolean result as well. In other words, you will perform manipulation on bool values using the operators. There are 5 Boolean operators that you can use, which are the not operator, and operator, or operator, is operator, and the in operator. We are going to see the meaning and use case for each operator. The not Boolean operator takes only a single Boolean expression and returns the opposite result. For example, if an expression results in true, then the not operator of this expression yields false and vice versa. For example, here we have x equals 5, y equals 12, and the variable truth contains a Boolean value of whether x is less than y. In this case, the value of the variable truth is true since x is less than y. The second variable is not truth. This variable uses the not operator to flip the Boolean value of the truth variable and saves it in the not truth variable. As you can see in the output of the code, the Boolean value is flipped. Now on to the second operator. The in operator works quite differently than the not operator. The in operator takes two Boolean input arguments and returns a single Boolean output. The in operator always returns false if any of the input arguments is false, but if both input arguments are true, then the in operator outputs a true value. Let us check out this example. Here we have 3 variables: x equals 1, y equals 2, and z equals 3. Then, we have three expressions e1, e2, and e3. Since z is greater than x, so expression 1 is true. Also, since x is less or equal to y, then expression 2 is also true. However, since z does not equal to y, then the third expression is false. Therefore, the expression e1 and e2 must be true since both expressions e1 and e2 are true, but expression e2 and e3 is false since one of them is false, e3 in specific. The next operator is the OR operator. This operator is similar to the AND operator in that it takes two Boolean inputs and returns a single output Boolean value. However, the OR operator, unlike the AND operator, returns true if any of the input arguments is true. If both input arguments are false, then the OR operator returns false value. Going back to our same example, we have expressions 1 and 2 to be true, and expression 3 is false. Therefore, e1 or e2 expression will yield true since at least one of the input argument to this expression is true. The same goes for expression e2 or e3. Now, let us look at the fourth Boolean operator, which is the IN operator. The IN operator checks for membership. Meaning, if a variable's value is incorporated in another variable's value, then the first variable is a member of the second variable and the IN operator results in true. If there is no membership, then the IN operator gives false. For example, suppose there is a variable x with string value of abc. If you would like to know if the letter a is in the variable x, then you can apply the expression a in x. This expression results in true since indeed the letter a is part of the string value abc. However, if you check for the letter f using the expression f in x, the result will be false since the letter f is not part of the string abc. Let's take another example using lists. Here we have a list of car names assigned to variable x, BMW, Mercedes, Tesla, and Kia. Variable y is only assigned with the string value Kia. Then, y in x results in true since the string value Kia assigned to the variable y also exists in the variable x. Trying a value which does not exist in x results in false. Now, let us discuss the last operator, which is the IS operator. However, before we dive into the IS operator, we need to understand how Python deals with variables. When assigning a value to a variable, our computer stores this value in memory and the variable name is used as a reference to this value. In other words, the values are not stored in variables. Everything in Python is dealt with as objects. Don't be worried about the meaning of objects in Python as we will study them in details later on in this course. But now imagine we assign the value 1.0 to the variable x. This line of code creates a new reference called x, which points to an object with value 1.0. This is one way to assign values to variables. Another method is to assign a variable to another variable. For example, creating a new variable called y and assigning it with the variable x will force the variable y to point to the same object, with value 1. Therefore, assigning a variable to another creates an alias which points to the same object value. Now suppose you have a list of integers assigned to variable x, and variable y is an alias of variable x. As mentioned before, creating this alias is done by assigning variable x to variable y. Now, we already know that x and y point to the same object with a list of integers. But why this issue is crucial in Python? The answer is that modifying one variable also results in the same change on the other alias. In this code example, we are appending a new value to y which is an alias of x. Also, we are printing the value of variable x before and after appending new value to variable y. As you can see in the output of the code, the change on the variable y is also reflected on the variable x. Now, sometimes having a variable as an alias to another one could be problematic, since updating one variable might unintentionally update another one. However, the good news is that this kind of bond can be broken in Python. This can be done using the copy method. What copy function does is that it creates a new object such that each variable points to a different object yet the same value. In this way, updating one variable does not affect the other one. Let us see an example. Here we have a variable x with a list of integer values 1, 2, and 3. Y has the same value of x but in a different object obtained using the copy method. Then, we are appending a new value equal to 4 to the variable y using the append function. As you can see in the output, the value of x did not change when the value of the variable y was updated with a new value thanks to the copy function. In this way, the bond between variables x and y is broken. Now the major question is this: how to know if x and y are aliases which point to the same object? This is where the is operator comes in. The is operator checks the identity of the object. If both variables are aliases to the same object, then the is operator outputs true, otherwise false. Let us revisit the examples we have done so far to see how the is operator works. In the case where variables x and y point to the same object, the is operator returns true since both variables point to the same object and updating one variable will affect the other one. However, when y is no longer an alias of x, meaning that updating y does not affect variable x, the is operator returns false since both variables do not point to the same object. Now, it is important that you do not confuse the is operator with the equality operator. Even though both variables x and y point to different objects due to the copy function, and the is operator returns false, still both of them have the same value contained in each different object that variables x and y independently represent. Therefore, the equality of variables y and x should still return true.